Hello and welcome back to PA Academy, and this is a continuation on our lecture series on two-port network. So in the previous part we look at the condition for symmetry in two-port network, and now we are going to be looking at that of reciprocity. So conditions for reciprocity or for two-port network to be reciprocal. So we are still saying the same thing. Alright, so now let's look at it in terms of the definitions. It says that a network is said to be reciprocal if the ratio of response to excitation remains the same when the position of response and excitation are interchanged. Exactly. All right. So now let's look at it in terms of mathematical representation as related to two-port network. Exactly. This is just the definitions. But let me just go through it again. It says a network is said to be reciprocal if the ratio of response to excitation remains the same when the position of response and excitation are interchanged. So when the position of the response and the excitation are interchanged, and then the ratio of response to excitation remains the same. Exactly. So if you are to look at it mathematically, especially when you are asked to check if a particular two-port network is reciprocal or not. So the conditions are actually different for all of those parameters. Exactly. So now let's start with that of Z parameter. So for Z parameter, for a two-port network to be reciprocal, that means our Z12, so our Z12 will be equals to Z21. So when our Z12 is equals to Z21, then we can conclude that that two-port network is reciprocal. Exactly. Then for Y parameters, if we should have our Y12 is equals to Y21. So if you watch the previous video on symmetrical, exactly, you should be seeing the difference now. Okay. And then for H parameters, so for H parameters to be reciprocal, so we are going to be having our H12 when it is equals to minus H21. Pay attention to that minus. Then for that of G parameters, that's going to be G12 will be equals to minus of G21. Exactly, so that's the condition. And then for ABCD, there are two actually. So if we have AD, so the product of AD minus product of BC equals to 1. Exactly. So let's just stick with that one. So once we have this, exactly, so these 4, these 5 are the conditions for a two-port network to be reciprocal. Exactly. I hope I've not mixed up with symmetrical. So that's the condition for reciprocity of a two-port network. These are the conditions. So this is for, let me just write it at the top. So this is for reciprocity. And then let me just put that on the side. Then if it is symmetrical, so that you can see the difference. So if it is symmetrical, you are going to be having Z11 equals to Z22. If it is symmetrical, you are going to be having Y11 is equals to Y22. If it is H, then that means you are going to be having the determinant of H to be equals to 1. And if it is G parameter, then you are going to be having the G, determinant of G, once it is equals to 1. And then this is going to be A is equals to D. So I hope you are seeing the difference in terms of reciprocity and the symmetric properties and the symmetry of a two-port network. Exactly. So basically that's what I want to cover in this video. If you find value in this, please give it a thumbs up. And if you missed the previous part of this video, please just check the playlist on two-port network and then you'll find all of the videos there. So with that, guys, I'll see you all in the next video. Thank you.